Hi guys, so we've been looking at oxidation of different molecules in chemistry, and we've also been looking at the flavour of food, and now it's time to put the two together. So the oxidation of food is caused from oxidation in the air, and it causes food to oxidize, which means to us it causes food to spoil. So to prevent the oxidation of food, there are several methods that are employed by the food industry. First of all, we try to pack food in the correct environment. So, for example, if you've got a bag of crisps, you usually find that the bag has had the air removed, or they've pumped in a gas like a kind of nitrogen or argon or something to stop or to try and remove all the air to stop that food from spoiling. They also try and use specific packaging like foil, which stops oxygen from penetrating through in order to stop oxidation of food, and also packaging food, like I said, in inert gases like nitrogen to try and have that nitrogen replace all of the air which is in the packaging of the food. So when a food spoils, what we are tasting is the products of oxidation, and we know now that aldehydes, which are one of the key flavour molecules in foods, the oxidation of aldehydes is to carboxylic acids, and the last thing you want to be doing when you're eating food is to be tasting a really sharp acidic taste. But when food spoils, that is what you're tasting, is the carboxylic acid which has been oxidised from an aldehyde. One thing that food industries can do to try and stop the oxidation of food is to add antioxidants into food. And one of the most common antioxidants is ascorbic acid. Now, the reason that ascorbic acid is so good at oxidizing food is because it will readily undergo oxidation itself. So when you put ascorbic acid or vitamin C into food, it will oxidize before your food oxidizes, and thus it protects your food from oxidation. Vitamin C or ascorbic acid is very soluble in water, and it oxidizes to produce this molecule here. So we can see that our hydrogens have decreased from 8 to 6, therefore our oxygen to hydrogen ratio is increased, but also we're losing electrons, which is oxidation. And we say that when edible oils are oxidized, they have become rancid. So to prevent oxidation, we require the use of fat-soluble antioxidants. Antioxidants are when edible and fats and oils are oxidized, free radicals are produced. And we're going to talk a little bit more about radicals in a couple of weeks when we do the skincare topic of this unit. However, when edible fats and oils are oxidized, we produce these free radicals. And what a free radical is a highly reactive species which contains an unpaired electron. So we know that electrons like to sit in pairs. Radicals are molecules or atoms which contain an unpaired electron, and this unpaired electron is very damaging. But free radicals can damage food by removing electrons from the molecules within that food. What antioxidants do is antioxidants work by mopping up those free electrons and protect the food, and antioxidants donate their own electrons to the free radical, which forms a stable pair of electrons, and this stabilizes the free radical. But during this process, the antioxidant molecule becomes oxidized and it loses an electron. And we could therefore write ion-electron equations to show how antioxidant molecules work, but essentially what they do is donate their spare or free electron to the free radical, therefore creating a pair of electrons which is no longer able to damage the food that you're eating.